This is lesson 4-5. Over the last couple of days, we've been dealing with triangle congruencies, but we're going to explore a little bit more into triangles. And with that, more specifically today, we're going to be dealing with the isosceles and the equilateral triangles. So hopefully by the end of this, you can say I can classify triangles by their side length and angles. Secondly, I know that if two sides of a triangle are equal, the angles opposite them are equal. And thirdly, the opposite of that, which is I know that if two angles of a triangle are equal, then the sides are going to be equal. Again, to start off with, just something we've seen before, but just to refresh our brains. So again, you might want to write this down. You do have it already written down, but again, for the test, just keep in mind that you will be wanting to know the different types of angles, because then that will allow us to talk about the different types of triangles. An angle is acute if and only if it is less than 90 degrees. Again, so if it's acute, then it's less than 90 degrees. If it's less than 90 degrees, then it's acute. Remember those two conditional statements and the converse of each other. Same is true then for our second one, which is if an angle is a right angle, then it is 90 degrees. If an angle is 90 degrees, then it is a right angle. Thirdly, obtuse angles, if and only if it is more than 90 but less than 180 degrees. And last but not least, straight angles, if and only if it is 180 degrees. More specifically though, when we're actually talking about triangles themselves, is a triangle is a scalene triangle if and only if it has no equal sides. Again, so if it's a scalene triangle, then it has no equal sides. Converse of that, if it has no equal sides, then it is scalene. These are straight definitions, so the converses of each other are both true as well. Isosceles triangles, if and only if it has at least two equal sides. And then finally, equilateral triangles, if and only if all of its sides are equal. And so you can make the argument that basically anything that's true for an isosceles triangle, as you probably noticed, at least two equal sides. Well, equilateral triangles, all of its sides are equal. So technically an equilateral triangle is actually an isosceles triangle because at least two of its sides are equal. It's kind of like the same thing as a square and a rectangle. A square is technically considered a rectangle just because it has those 90 degrees on its angles, and we'll talk about quadrilaterals a little bit later. But just know that for an equilateral triangle, all the properties about isosceles also hold true for that. So to first start off with, our first theorem in our lesson here is if two sides of a triangle are equal, the angles opposite them are equal. And so as you can tell, this is based off of an isosceles triangle because both of the sides are equal. And so then we are going to, we can assume that then basically, because it's isosceles, I know then that the angles are equal as well. And we are going to prove this later on in class. Based off of that theorem there, so if I know that the sides are equal, then that means that I should know that the angles are equal. And so if I'm going to ask you what is the measure of angle A and the measure of angle C, you're going to know that because it's an isosceles triangle, because here's 13 and here's 13, that both A and C are going to be equal to each other. Now, how would I figure out basically if it actually is, or what that actual measurement is? And so if you could for me right now, I'd like you to pause the video and I want you to actually try to see if you can figure out what the measure of angle A is and measure of angle C on your own. And then once you unpause, then I will go through the answer itself. So hopefully you paused it, and then now I am going to kind of go through how it actually would work out. Think about it again. Think back to back in our earlier chapters. How many angles, basically, or how many degrees make up a triangle? We should be able to say that's 180 degrees. And so if I know that one of the angles is 125, basically I'm going to take 180 and subtract out 125, and that would give me 55 degrees. Now, I know that both of these angles are equal to each other, so if I add both of them together, they should equal 55. And so if I take 55 and divide it by 2, I would get the measure of angle A, which is 27.5 degrees, and which is equal to the measure of angle C, which is also 27.5 degrees. Theorem 10 is just the opposite of that. So if two angles of a triangle are equal, the sides opposite them are equal. And so if I know that in triangle ABC, if I know that the angles are equal, then I should be able to conclude that the sides are also equal. And so again, here's another situation in which after I explain it, I want you to pause the video and then try this out, and then I'll go through the answers after that. But first, again, so I know that the angles of these triangles are equal, which then would mean that I know that AB is equal to BC. This angle then matches up with the BC, and this angle matches up with AB, so I know that they're equal. Now, if I'm going to ask you basically what is the side length of AB and the side length of BC, so if I know that they're equal to each other, I got to think to myself, okay, what could I use from this, basically this picture itself, to figure out the length of AB or figure out the length of BC? Well, I know that the height from B all the way down to the base AC is equal to 5, and I know that creates a right angle, so that's my perpendicular bisector. And then I also know that this entire length here is 24. This entire length across here. So if you could try to figure something out, so pause it for me, and then I will go through the answers here in just a second. So again, this is a number 24 at the bottom if it's getting cut off. So again, I hope you paused it, and I want you to take a look at basically half of the triangle is my hint to you. So just looking at, just cutting off this half here and just looking at from here over, I know that basically this would create a right triangle. And so thinking about the fact that, okay, so I know this length, and I technically know this length because 24 divided by 2, if I'm cutting it in half, is equal to 12, would I be able to figure out the hypotenuse? And so hopefully this is starting to sound like the Pythagorean theorem, where I know if A is equal to 5, I know that B is equal to half of 24, which is 12. I should be able to figure out what C squared is based off of that, my hypotenuse length. So 5 squared is equal to 25, 12 squared is equal to 144, so I'm going to add those together to make 169 is equal to C squared. Again, add them all together, and then now I want to basically figure out what just C is. So how do I get rid of squaring something? Well, then I would take the square root of both sides. The square and the square root cancel each other off, and so I'm left with the square root of 169, which hopefully, without a calculator, you can realize is then equal to 13. And so I would be able to confidently say that measure of AB, which I know is equal to the measure of BC, they're both equal to 13 units. Lastly, basically some corollaries to the theorems that we talked about before, because again, if I know one thing about an isosceles triangle, I should be able to then apply it to an equilateral triangle. I should know that an equilateral triangle is equal angular. So equilateral, equal sides. Lateral means sides. So if I know that a triangle has equal sides, I should be able to know that it has equal angles. Obviously, hopefully you're saying to yourself, okay, so if I asked you how many angles does actually each angle of a equilateral triangle equal, you'd be able to say, well, let's see here, that's 180 divided by 3, so that's 60, so that should make sense to you. But again, using the properties from before, if I know that two sides are equal, and then I just kind of rotate the triangle around, and I know that those two sides are equal, then I know that all the angles would be equal as well. And the opposite of that, which is, or kind of the flip of it, which is, if I know that a triangle is equal angular, then I would know that it has equal sides, it's equilateral as well. So that's it, that's all I have for you. So again, make sure that I'm able to see these notes tomorrow in class, and then we'll be able to work on the homework then. So thanks for listening, and I will see you next class period.